Hey everybody, this is Larry. This is day 21 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about today's poem, Triangle. So I usually start these live, so it's a little bit slow, let me know. I also have crazy allergies, so you see me like looking crazy a little bit. My eyes. That's it's seasonal allergies and it happens every time this time of year, but last year I got away from it by just being in Hong Kong in another country. I don't know why New York is always like this, but um, anyway, triangle. I given return a minimal path from top to bottom. Okay, so this is a way. There are variation of this, but this looks to be a race fundamental dynamic programming problem, and you can do this recursively for sure. But I think these kind of problems is a um, good good first try at bottoms up because the for loops I find anyway to be a bit more intuitive than going. I mean, not more than top down because top down is pretty straightforward as well. But it allows because here the key thing to note is that on every row the result of every row is based off the result of the previous row, right? And because of that, and in this case, I mean, it's not always the case of dynamic programming that the ordering is obvious. But for me, anyway, this this problem or similar ones where it's a rectangle instead of a triangle going from top to bottom, it feels more obvious that you're going from row to row, so the ordering is more obvious. And in this case, it doesn't matter if you go left to right or right to left, I believe, though, it's not always the case. But yeah, so for that reason, I'm going to go through it with dynamic programming, bottoms up. Cool. I'm just checking the sound because sometimes my mic goes crazy. Okay, and you can, oh yeah, in the file you can only do this if O of n extra space. You can actually technically just modify the input, of course. I always advise against it because what people calling your function will be like, why are you modifying my input? But yeah, so actually let's do, okay. What I'm going to do is I'm going to do this bottoms up, and then I'm going to do the space optimization and then submit it. Okay, cool. So basically the idea here is, okay, let's do the two-dimensional one first. So let's see how this is specified per se. So n is equal to the length of triangle, and then now let's just create an n by n matrix. I know that this is a triangle, and you could do n by n over 2 instead, but just for the sake of keeping it simple, yeah. So actually, let's set this. What do we want to find? Minimum. So let's set this to infinity. Times n for right. So now we have an n by n matrix on DP. And then now let's go for triangle one at a time. So for I think I is okay in this case. So for I is the row, and for each row we have I number of items. Yeah, and also let's start with the default thing of this is the case. Because we set this as the base case, we have to add one to these things, I think, or just to be safe. To be honest, I mean, you can work that out how precisely to make it, but that's how I do it. Okay, but then now, what is dpij, right? Well, actually, technically, I guess it's I plus 1 j plus 1 because we need the offset to go for the 0 0 is equal to let's see. So the sum, so given this cell, what can it do, right? It can either come from here, and that's it in this case. But let's say let's looking at this 5, it could come from the 3 or the 4. So then we basically take the minimum of those two because this is that's the way that we do it, I guess. But yeah, but this is relatively okay. So this is going to be equal to, say, and now I'm just trying to think about the correct index. So ij will go to I minus 1 j minus 1. yeah, I minus 1 j, and so that's the right side is that they have the same j, and then the left side is if j is j minus 1. So let's do that. So we take the min of those two. So we have dp I, and this is a little bit so this is the and that's what we're looking at. And then as we said, we minus 1 j plus 1 minus 1. So we take the min of this or this, plus try, and technically if you want to be more precise, but you'll see it this way, you'll see people do triangle ij, and we have to do an if statement to make sure that it doesn't go around, but that's fine. Give me, but in this case we can obviously take it out. Because the min of, and technically this can go out of bounds, but because of our extra padding, I think we're okay. Yeah, because of our extra padding, I think we're okay because it just defaults to infinity. And this is how, and just to be saying, just to say it one more time, just to be clear, the reason why we have a plus 1 here is because we have an offset that, just that, let's define ij is equal to the minimum total of path from 0, 0 to I plus 1 j, no, I minus 1 j minus 1, right? So that's basically to be precise. So if you want to move this minus 1 to plus 1, that's how we get the plus 1. And the reason why we do this is so that we can handle the base case in a clear way, so we don't have to worry, because and you could kind of be more precise. You could define it in any other way, but that's the way that I do it, because then now you don't have to worry about the base case, because otherwise you have to put like if statements here with if I is equal to 0 and j is equal to 0, some funky things like that. But yeah. Okay. And let's start this at 1, though. I think it doesn't do anything, obviously. But yeah. And now let's just return, at the very end, we return dp of n, because of course this is the last row and last column, because again, if you want to think about it this way, is n plus 1 minus 1, right? Oh no. And again, of course, I write it out just for educational purposes. But now let's take a look at dp. Maybe I forgot to set something. Oh, I think this does. I think I've been off by 1 as a result, and that's my, because now it doesn't go to. Oh yeah, because we have to process. Yeah, we have to do, this has to reach 0, 0, so I think we need something like this. Oh, yikes. Let me take a look. So 0 and then 2 after the first one. That this one's good. 5 and 6. So that's how I debug, is that I look at the output and then look at the expected things. No, this is. Oh! I'm silly. Okay, I forgot that. I'm. See, this is one thing of when you solve in a problem, sometimes you take shortcuts without thinking about it. And this one obviously actually doesn't make sense. It's just that I wasn't thinking about it because I've done too many dynamic program problems, and sometimes I type things without thinking about it. But what you want is, what is the answer now, right? The answer is the minimum sum on the last row. So that means that on the last row, we just take the min, right? So we don't, here I took the last set, like basically on a corner cell, which happens a lot, but actually in this case, we actually want the minimum sum on the last row, so we want this. So now this should be good. Oh, is there a negative? Did I handle negative correctly? I think we're okay. Actually, I don't know because I set this as 0, so this may not be. Oh, okay. Yeah, I think this is okay. Yeah. So, you want to test cases, maybe this is okay, right? So this is, of course, how you would do it in. Let's go through the complexity before I submit, because then I want to do the space optimization one. The space complexity, if you look at this is going to be n squared, and that's all there is. In time complexity, you have 2 for loops, and this is also going to be n squared over 2 or something like that, which is still O of n squared. So O of n squared time, O of n squared space. And then now we want to do the space reduction. Let's see, which is part of the follow-up, I think. But yeah, the one thing to note is that as we talked about this, as we looked at this recurrence, one thing to note is that I plus 1 and j plus 1 only depends on. Let's actually compress this for now, so that it's slightly easier to read. Because now you notice that the row of y plus 1 is equal to they only change dp sub I, right? Depend on dp sub I. So that means that to solve dpi plus 1, you do not need dpi minus 1 or dpi minus 2 and so forth, right? So then now you can almost and the way that there are different ways to think about it. The way that I'm doing it is just to demonstrate a point, so that it's just for teaching purposes. So if you're a Python master, you may not do it this way, but yeah, but you can look at previous. Let's just say previous is equal to dp sub I, and current is equal to dpi plus 1. So this is just aliasing, right? So then now you can set this to current. This is previous, and this is previous, and then this is going to be the last current, I think. So yeah, let's run this real quick. Yeah, still the same answer. Of course. So now we did this move, which is fine, but right, this is still n squared because we have the dp thing, right? But then now, and there are different ways of doing this, but I'm going to just put it this way: instead of a n by n array, we can create just a 2 by n array, right? Because noticing that we only use this, so now we have 2. I think so, yeah. And here, now that you notice you only have 2 arrays, you basically, you just mod 2 in a circular kind of way. The only other thing that I might say, which is that you have to reset. You have to depending on the problem. In this case, you don't have to, because we overwrite it without the way that we wrote it. We overwrite it anyway. But sometimes you have to reset previous or current after you use it. And there's different, like I said, there's different ways to writing this. But whoops. It may not do the first row correctly. But yeah, like I said, there are different ways of writing this, but that's the general idea about the space optimization. And as you can see, there are weird edge cases that may come up, so you have to be really careful. But that's the idea. Let's see how can we solve this, because I think previous. It may be that it may be that because of my offset, this is actually technically incorrect, because what I want to do is something like this instead to begin with. So we have to offset it by 1, maybe. Let me double check that. That's not right at all. Okay, let's see. So reset. Oh, no, this is right. Chrome sub j. Okay, let's just print it out then. Like some weird off by 1 based on the base case, which is sometimes a little bit. This is right. This is right. This is right. Oh, this is 0. Oh, okay. So I was wrong about what I said earlier. Like I said earlier, you have to be careful about resetting the things, and because we didn't reset it, the 0 that carried over from here to here. So that is because you're using the same space. I forgot that we don't. Well, this is the only cell where it doesn't get overwritten, so then it carries forward a little bit, which is a little bit silly. But yeah. But in this case, what you want to do is you just set let's see, for index in which one do we set? Previous, because then I guess this is just n. So I mean, you can do a little bit better a bit. Yeah, so there you go, basically. And the reason why we did it this way instead of something like it is because this would allocate new space, which kind of, I mean, yeah, for learning purposes doesn't really matter, I suppose. But yeah, but that's basically the idea. And then now let's give it, we have to reset it. I even mentioned this, but I thought that we didn't need it, but we our base case made it so that we do. So yeah, let's give it a submit. So yeah, accepted, that's cool. Like I said, this is going to be n squared time, and you can see that this is an n of n space because we only have 2 rows. Okay, that's all I have for this problem. Let me know what you think. Hit the like button, hit the subscribe button, join me on Discord, and I will see you tomorrow. Yeah, to good mental health and all that stuff. Bye bye.